Welcome to Lesson 7, Co-Creation, the first lesson in our last module, Solution 1.0. After completion of this lesson, you'll be able to 1. Design a prototype to share with users that reflects not only the assumption you want to test, but also how you want to test it. 2. Determine what data to collect from users and how to make sense of it. And 3. Use the feedback from your users to decide whether to pivot or persevere with your innovation. To begin, what do we mean by co-creation? Simply put, co-creation refers to the process by which you develop and refine your innovation with the help of others. And while there are many ways to co-create, we focus this lesson on the build, measure, learn feedback loop. Now, some of these terms might sound familiar since we've touched on them in previous lessons, but we dig more deeply into them here, since they're so critical to your success as an innovator. So, in this lesson, we will connect and extend these ideas in order to provide a roadmap toward the iterative learning that is essential to a successful innovation. So let's dig in, starting with the first step in the loop, build. When deciding what you want to build, you need to answer two questions. 1, what assumption will you test? And 2, how will you test that assumption? As we discussed in lessons 5 and 6, knowing what assumption you want to test is critical, since the features related to that assumption must be central to the prototype you build. This is why, in our example from lesson 6, we suggested that if you want to test the assumption that users of tunable noise-canceling headphones will be willing to be actively involved in their music delivery, your prototype should consist of a low-fidelity app interface and not the headphones themselves. But knowing what you want to test is only half the battle. You also need to give some thought to how exactly you want to test it, since the method you choose will influence the prototype you build. There are lots of different methods you can use to gather your feedback data, but they can generally be grouped into 4 broad categories based on whether you want to explore, compare, assess, or validate the assumptions you have about your innovative project. Exploratory testing works best early on in the innovation process, as it's designed to enable you to explore users' feelings, thoughts, and overall reaction to your idea. Prototypes at this stage tend to be very simple and low fidelity and focus on assumptions pertaining to basic core user pains and gains. Comparative testing is used when the idea is a bit further along and you want to compare 2 different ways in which your assumption might play out. For this type of test, you'll need 2 prototypes that are identical except for the 1 or 2 key features related to the assumption you want to test. Assessment testing is used to evaluate the overall usability of your product or service, so it's best used further on in the process once you have confirmed that your idea solves a problem that users are facing. Here, your prototype would have basic functionality so that users can interact with it enough to assess whether and how effectively 1 or 2 key elements perform. Validation testing is conducted in the later stages of the process when you're looking to test more trivial assumptions about your innovation and/or whether it does what you and your users hope it will do. As you can see, how you test your assumption depends on both how far along you are in the process and the type of assumption you're trying to test. And because each approach requires a different kind of prototype or set of prototypes, you must design your prototype with these factors in mind. So, back to our headphone example. Suppose from a previous assumption test that you've confirmed that users are willing to use an app to customize their music delivery. However, you're unsure how much technical functionality the app should have, and this has led to a new assumption that the app should have as much functionality as possible to allow the greatest amount of customization. This assumption requires a comparison, as it's a question of more versus less functionality. Given that you're still relatively early in the process, you would opt for a comparative test between two low-fidelity prototypes of your app. You'd create a simple prototype with just a few options, and a more complex version with lots of options. Now that you know what you will build and what testing approach you will use, the next step is to share what you've built with the users and measure their reactions. So let's dig into that. There are two general ways you can do this. The choice depends on 1, the amount of feedback you want, and 2, the amount of time and money you can dedicate to testing. Moderated testing is when someone works directly, either in person or synchronously online, with users to solicit and record their feedback on the prototype. Because the moderator can interact with users and react to their questions and problems, this process can provide very detailed, granular feedback on the assumptions you're testing, as well as a range of additional issues you might not have even thought about yet. However, moderated tests are time-consuming and expensive, and can usually only be conducted with a small number of participants. Unmoderated testing is when users interact with the prototype on their own, without any direct supervision, and then provide feedback via a questionnaire, which is often completed online. Due to the asynchronous online nature of unmoderated tests, they tend to be much cheaper and can reach more users than moderated testing. And because the questionnaire must be developed before users interact with the prototype, unmoderated tests are great for getting answers to specific questions related to your assumptions. However, they're not good for much else. You won't come across new issues you hadn't thought of or get interesting, surprising data. As you can see, neither testing choice is better or worse. They're just different and are chosen depending on how many users you want to engage, whether you are more interested in qualitative or quantitative data, and how much time and money you're able to invest in the process. Let's go back to our tunable noise-canceling headphone example. In Lesson 5, we proposed that one way to test whether users value music sound quality but want to avoid shutting out all ambient sounds, such as traffic noise, is by having someone explain and demonstrate with a prototype how the headphones work to 40 audio files. This type of approach would be an example of exploratory moderated testing that would require a single low-fidelity proof of concept designed specifically to demonstrate the noise-canceling effect. Of course, deciding on the type of test you want to conduct and building the prototype is only step 1. Next, you have to conduct the test and measure the results. In this example, the moderator would interact directly with users in order to better understand what they truly think about the overall idea and why. To do so, the moderator would record users' responses, their nonverbal cues, follow-up questions, and the like in order to capture not just whether users liked the idea or not, but the emotions, feelings, and concerns that underlie their overall reactions as well. This process of data collection is essential to successfully implementing the measure step in the build, measure, learn feedback loop. It will form the foundation of the learning that comes next. The good news is that at this point in the process, you have the data you need to validate the assumption you want to test. The bad news is this data can sometimes be hard to make sense of. Nobody said being an innovator was easy. On the one hand, your qualitative data can seem difficult to compare and interpret. On the other hand, your quantitative data may have outliers that can complicate and skew your analysis. And chances are, your assumption test generated both types of data. While the challenge of making sense of it all might seem daunting, don't fret. You've already learned the skill you need to find the underlying patterns in your data, synthesis. Recall from Lesson 3 that synthesis is a process of sense-making by which we connect disparate pieces of data to reveal a larger, often hidden, pattern. Although we presented synthesis in that lesson as a way to understand your problem space, the same technique can be applied here too. If your synthesis skills are a bit rusty, it might be a good idea to go back and review that video. Either way, the key is to put your data in physical form, lay it out, and try to combine similar elements together into clusters, and then consider how those clusters relate to one another in a way that informs your assumption. Back to our headphone example. We suggested in Lesson 5 that at the end of our test, if 10 of the 40 users registered to find out when the headphones will be commercially available, our assumption would be validated. This was an intentionally simplistic metric, as our primary focus in that lesson was on how to identify the assumptions we're testing. In reality, if you were to conduct an exploratory moderated test to test the assumptions that users want headphones that cancel only specific sounds, you would likely get lots of data about your users in addition to how many of them want to be notified when they hit the market. For example, you'd see variance in how interested they are. Are they really interested or just curious? And how would you actually know how interested they are? Well, what facial expressions did they exhibit during the demonstration? Did they ask follow-up questions to learn more? This is the qualitative data that gives context to your quantitative data. So, back to our example, if only 9 users registered, but they were super excited about your idea, that might actually be better than if 10 registered, but none were overly enthusiastic. In other words, it's this interconnection among all of the data you collect that enables the real learning you need to actually test your assumptions. Done well, testing can create data with interesting nuance that you can synthesize into a deeper understanding. At this point, you've built some prototypes, measured response to them, and synthesized your data into some important learnings. Now what? It's time for some important decisions. If you learned from your test that your assumption was correct, then you can continue to move forward with your idea or persevere. That's great. But if you learned from your test that your assumption was wrong, you will need to change direction or pivot. While this may not be the outcome you were hoping for, don't fight it. Just be glad you found you were heading in the wrong direction before you spent any more time and money. Maybe the feature you thought was important doesn't actually solve the problem. Maybe you weren't focusing on the right target user. And then use what you've learned to revise your thinking. Describing your decision as whether to persevere or pivot is a simplification, of course, since there are lots of shades of gray. For example, you might persevere with your product as is. You might persevere but make modest changes to your product, such as adding or cutting features. You might persevere with your product but pivot to a different target market, or pivot to a different product but target the same market, or pivot to a completely different product and target market. And most importantly, as you decide whether and how to pivot or persevere, you should also start thinking about what assumptions to test next. This is why it's called the build, measure, learn feedback loop. As we discussed in Lesson 5, you'll have many assumptions underlying your innovative idea, and you'll want to test all of them in order to give your project the best chance to succeed. So this is an iterative process in which you'll build multiple prototypes, measure lots of user feedback, and use what you learn from those tests to persevere with your initial idea or pivot to something different. It seems like a lot of work, and it is, but by focusing on low-fidelity prototypes early on in the process, you can run through loops quickly and cheaply, making it well worth the time and effort. Let's summarize what you've learned. In this lesson, we've seen that innovations have the best chance for success when they are co-created with users. Only by allowing users to experience the way you're thinking about your innovative product or service can they help you understand whether and how it actually solves real problems for them. We then learned that while there's no shortage of ways to involve users in the innovation process, the build, measure, learn feedback loop is a great way to structure this process. Based on the outcome of this process, you will be able to confirm or refute your assumption, which should lead you to either persevere with the current course of action or pivot to something new. Lastly, we highlighted that most innovative projects have lots of assumptions that need to be tested. So this process is a true loop that will require many iterations in order to bring your innovation to life. So what's next? Well, you've now completed the first lesson in our last module. You're almost home. You've just got 2 more lessons left. In the next one, you'll learn how to identify the resources you need to move your innovation forward, as well as how to mobilize those resources. And in the final lesson, you'll learn how to get others excited to be a part of your project.